So I am back at it again. I'm going to start this next one, even though it is really long. Okay, this one's long because it has percents in it. And as a math teacher, no matter how old your students get, they always mess up percents. I don't know why. I really don't know why, but we're not going to mess it up. So I'm going to share my screen, and this will be a two-parter because I know I'm going to run out of gas at some point. But here we go. If you have percents, right? And we're also going to do everything with modeling. So it's modeling, tons of modeling problems, tons of fractions, tons of percents. My teacher who inspired me to be a math teacher, well, there's three guys. They're all great. They all worked at University of Las Vegas, Nevada. One was Dr. Stallman. He basically wrote the book or all the articles of the chapters on modeling. If you're interested, look him up. He's so smart. So modeling, decimals, whole numbers, fractions, and percents. But for just percents, remember this is percent. It tells you what to do. We have 5% of 30, right? Very simple. 5% is 5 divided by 100. Per means to divide. Miles per hour, points per game. Cent means 100. So divide this by 100. 0.05. You could also just move the decimal place once, twice. 0.05 of math means multiply. 0.05 times 30. Well, what's 30 times 5? That's 0. 5 times 3 is 150. We're going to move it how many times? Uno. Dos. Just dos. 1, 2, yeah, two places. So what is 5% of 30? The answer is 1.5. 5% of 30, this whole thing is 30. 5%, a little 5% slice is going to be 1.5. That's really all it is. Now I'm going to do a ton of problems, but I think this is the best place to start is just to really think about percentages and modeling and everything else that goes along with it. So here are the decimals ones. Obviously, just do the ones that you can't do, practice them. They're all for you. So I got all of these problems, as many percent things as I could find. But let's start with the model. All right. So let's find the value of y in this diagram below. So we know we have 1, 2, 3, 4 y's and 22 to make 30. So we just have to figure out how much the y is. If I know that the whole thing is 30 and I'm using 22, I got to subtract 22 from that. So I got 8. So this means this is 22. This means this whole other part. So I got 22 here. And I have 1, 2, 3, 1, 2, 3. I got 4 y's that make up 8. If I want to know 1 y, 4 y's equal 8. What does 1 y equal? Got to equal 2 because look, 2, 2, 2, 2. We got it. And we did the exact same thing they did, which is always nice. All right, so let's try the next one. So here's the next one. We got to find the value of A in this tree diagram below. This is using the distributive property, right? We have to know what all of our properties are. So I have A minus 10, another A minus 10, and another A minus 10. Well, what's another way to write this? Because these aren't multiplied, they might seem that way, but these are being added together. So if I have 3 A minus 10s and that equals 12, the best thing I can do is distribute this. So that's 3A minus 30 equals 12. So all we have to do is figure out what that has to be. So we're going to add the 30 to both sides. So 42 equals 3A. Divide both by 3. And A is, well, that goes in one time with 1 left over. So 3 goes in 12, 4. So it's 14. Your correct answer is 14 plus 14 plus 14 minus 30 equals 12. Beautiful model. Nicely done. All right. All right, now I got a multiple choice. So which of the following corresponds to the diagram? So the whole thing has to equal 25. So right away, we know it's got to be this one. 13 plus 1, 2, 3, 4 z's. Well, that was nice. It just shows you what it actually means, the diagram. Beautiful. All right, so now we have MC. Oh, it's another multiple choice. All right, so 1, 2, 3, 4, 5 of these. equals 104. So 5 times x plus 7 equals 104. Nice. Nicely done. All right. So now let's do another distribution area model. So here's another model, but now we have decimals and crazy stuff. So let's figure this out. So -4 times -2, that's a +8. And this one is 2.3s. So 2.3 times 4. Well, I just think about it as 23 times 4. That's a 2. 4 times 2 is 8 plus 1 is 9. We got one decimal. So this is 9.2s. But there's a negative sign. So we know that's a negative 9.2s. And this two negatives make a positive. So the answer to this thing is going to be a negative 9.2s plus 8. That's your final answer. Ta-da! Nicely done. If that's too confusing, try a couple of them. Now let's try an area model. All right, here's another area model where we're multiplying to get 4d plus 10. So it's 2 times 4d plus 10. So 2 times 10 is 20. Well, 2 times 4 is 8. And basically 1 times d, because there's no d's there, you just drop it. So your final answer is going to be 8d plus 20. Nice. I believe that this one is easier than the last one, so I'm going to move it up one. Oh yeah, because that was level 2. All right, so let's do an area model with fractions. We've done this one before, but I just wanted to show it again because I like the animation. I think it's useful. So 2/3 means we have 3 parts with 2 shaded. Then we have 8 parts and 3 shaded. I have to drag this on the top. Cool. So how many little rectangles are overlapping? 1, 2, 3, 4, 5, 6. And how many in total are there? Well, it's 3 times 8, which is 24. Oops. All right, so we know the answer is 6/24, but we can simplify by crossing those out. So 2/3 times 3/8 can cancel them. And we can be left with 2/8, which is 1/4. That's the simplified form. Oh, they went unsimplified form. Sorry. So 2 times 3 is 6. 3 times 8 is 24. Nice. I gave you the simplified answer. Whoa, 1/4 of the picture. All right, so let's do one of these with 2-digit multiplication. All right, so this is tough. So enter the missing values in the area model. Okay, so I believe this is 6 and 0.8. And this one's going to be 0.20 and 0.06. Nice. So we're breaking this into pieces. So if you can't, this is the way that I multiply, right? 6. I got to reload the page, really? I guess so. All right, so I would normally just multiply 68 times 26, and then I would just move them over. So if we want to do this one at a time, 6 times 2 is 12. And we have one decimal, because I only use one of the points, so this is a 1.6. 20 times 8 is 1, or 2 times 8. I'll show you what I mean. 6 times 6 is 36. And then we have how many decimals? 1, 2. So 1, 2, so it's 0.36. 6 times 8 is 48. How many decimals do we have? We have 1, 2, 3. So we have to go 1, 2, 3. So this is 0.048. Nice. and I'll do this one by hand. Well, this is how I would do the problem. I would do 68 times 26, and that's gonna be 8, carry the 4, 36 plus 4 is 40. Then I would put a 0, because not times by 2 is times 20, that's 16, carry the 1. 2 times 6 is 12 plus 1 is 13. So our answer is 8, 6, 7, 1. And we have 1, 2, 3 decimals already. 1, 2, 3, 1.678. That's how I would do it. For this piece, we have 0.2 times 0.8, which is just 2 times 8, which is 16. I have 1, 2 decimal places, so it's 0.16. So if we add all these together, we should get 1.768. We did it. And there's the add step that I skipped. I skipped that add step at the end, but we got all the answers right. All right, so let's do another area of a whole. So answer the following questions to fill in an area model. So it's 7 times 48. Which multiple of 10 is closest to 48? So if we can't do, this is how we're using the model, right? 7 times 48. We can't do that. We can do 7 times 50. I believe that's what we're going to do. All right, and what's 7 times 50? 7 times 0 is 0. And 7 times 5 is 35. So 350's got to be close to the answer. All right, so now we have one that's big, but we want to take 2 away. So 50 we use, but we really want 2. So this is our model area. So 7 times 2 is actually 14. So we're not taking away 2, we're going to take away 14 from the total. And 7 times 48, well, if we know the whole thing is 350, 350 minus 14 is 336. So that's our answer, 336. We got it. So that's the way to use modeling, an area model, to really help a student understand how to multiply 2 big numbers that might be scary for them. I think it's a really useful method. All right, so let's look at a conversion. Sweet, I knew we were going to get to do some conversions. So we're going to convert 4 tons into pounds. So I have 4 tons. So 1 ton is 2,000 pounds. So I have 4 times, we always put what we want on top and what we have on the bottom. So they're telling us 1 ton equals 2,000 pounds. So ready, the first thing we have to put is, what do we have? Well, we have tons, right? So that's what goes on the bottom. The 1 ton goes on the bottom. What goes on top? 2,000 pounds. So that's how we work it out. We just multiply. This is really 4 over 1. 1 times 1 is 1. These are in tons, so that's why they cancel. That's why you always put what you have on the bottom. 4 times 2,000 is 8,000. So that is the correct answer for the conversion. 8,000 pounds. It's always what you want to get. In our case, pounds. What do we have? Tons on the bottom, so they cancel. All right, well, I got to reload the page because it did not want to give us the answer. Here's our 8,000 pounds. Let's make sure that's correct. It is, and they did the same thing. What do they want? Pounds, tons on the bottom, those cancel. Beautiful. So we just did conversions, and let's do another convert. We'll do like 2 more conversions. All right, so now we want to convert 7 yards into meters. 7 yards to meters. That's the goal. So I can go yards to feet. And then yards to feet, feet to miles. miles to kilometers, kilometers to meters. Wow, that's a long process. All right, let's do it. So here's the first part of the conversion. 7 yards. We're going to multiply what we want. Let's turn this yards into feet. So that's going to be 3 feet for 1 yard. So now I have how many feet? 7 yards is 21 feet. Cool. So now let's take this feet and turn it into miles. So we have 21 feet. I'm going to put what we have on the bottom, which is 1 foot. Oh, sorry. On the bottom, we're going to put 5,280 feet. And then what goes on top is 1 mile. So we actually have to divide. So the feet cancel. We turn into miles. So we have to do 21 divided by 5,280. So that's going to be 0.003977. So that's how many miles we have, okay? So we have this in miles. Then we can take miles and turn this into kilometers. So we have this in miles. We have to multiply this. We want in kilometers, so that's 1.609 divided by 1 mile. And this is going to give us kilometers. So I have to take this number and multiply it by 1.609. And that's what we have in kilometers. So now our kilometers is 0.0 0.006399, 0.006399 kilometers. And we want finally the 7 yards into meters. And we know 1 kilometer is 1,000 meters. So we have to multiply this by 1,000 meters, and that'll get rid of the kilometers. Or we can be fancy and just move this once. It's 6.39, you know. They want us the nearest hundreds, so 6.399. So I'm just going to take this and multiply our final answer by 1,000. And we want this to the nearest hundredth, so 6.39. Well, the hundredth is here, but this is more, right? So we're left with 6.3994. Remember, this is your 10th place, this is your 100th place, but this brings it up 1. So it's actually going to be 6.40 is going to be rounded. I know that was the circuitous path, but these were the only conversions they gave us. And we got it right. And these were all the steps. Oh, I could have just put into the other way. Oops, I didn't know it had yards to meters, but we still got the same answer going harder. Maybe let's look at one more. And one more conversion. Okay, so an object is moving at a speed 4 feet every 8.5 years. Express this in centimeters per day. So if I have 4 feet in 8.5 years, we have to change this, right? Because we wanted this in, so we have to change this all into centimeters and change this into days. And here, I'll just show you the steps because this one's really hard. So not only do you first have to change the feet as you go through, you also have to change the years. This one's really hard. For elementary school math, I feel like this one's out of the range of what you need to do, but that's okay. But basically, all you have to do is set up the conversions where all the units match. So feet to feet, meter to meter, centimeters, right? Because that's what we want. So we're just doing feet first, then we're just doing years, right? So once we have the feet into this, then all you have to do is just change this into years. It's really complicated, but I might as well show it to you. So 4 feet, 8.5 years. Let's just mess with the feet first. So let's look at the feet. To do the feet, we want this into days. All right, so I mean, we want this to centimeters, so feet to centimeters. So we want this first into inches. So we're gonna do 12 over 1. So 12 inches over 1 foot. So those cancel. So now we have 48 inches. And if I want inches to centimeters, it's down here. So now I have 48 inches. So that's 48 inches. And we want centimeters, so that's 2.54 centimeters over 1 inch. So that's all we have to do is multiply 48 times 2.54. So we're left with 121.92. So there's our centimeters. Now all I have to do is I have 8.5 days, but remember this is on the bottom, right? It's on the bottom, but we still want to take the days. I mean, we want to take the years and turn this into days, right? We just have to remember it's on the bottom the whole time. So I want to make this days. So I have to put years on the top. So how many days in a year? Well, it's 365. So I have to put 1 year times 365. Those will be canceling. And now I just have days on the bottom. So it's 8.5 times 365. So we have the top, which is centimeters, and then we have the bottom, which is 3102.5 on the bottom. But we just want it is not in that day, we want it in just 1 day. So how many centimeters per 1 day, right? Because this is all we want for the answer. So all I have to do is divide this number because it says 1 day. So if I have 3,102 days, I just want to make this 1 day. All I have to do is take 121.92 and divide it by 3102.5. That's going to be our final answer. So 121.92 divided by 3102.5. Our final answer is, what do they want this in? 1 to the nearest hundredth. So that's 1, 2, it's 0.04 centimeters per day. And we got it right. Ta-da. Nice and easy. All right, so I'm going to pause here. We're about a third of the way done with this one. We'll see if, as far as I want to go. We'll do some of the volume ones. I know it's geometry based, and then I'll do all the percents. I know the percents, there's so many. So I hope this was a good first half of this one, and just reach out if you need any help.